So my name is Nihar Modi. I lead product management for Amazon Managed Blockchain. The agenda for the day is, today we're going to learn a little bit about blockchain. We will dive deep into the service. We'll follow that up with a bunch of good customer stories and how they're leveraging blockchain in their solutions today. And that will follow up with Casey, who will talk about Workday and how they're incorporating blockchain into Workday's solution. So let's get started. What is blockchain, right? So before we do that, I want to talk about what inspired us, right? And this is somewhere around 2017, 2018 timeframe. We started reading a bunch of press articles about blockchain as to how it was going to be the backbone for supply chain 2.0. We also read a bunch of articles about how it was going to change the finance industry, right? We also read about a bunch of stuff around how blockchain was going to transform the healthcare industry. So when we started reading all of this, we looked at ourselves and we decided that, hey, we should go and talk to a bunch of customers to really understand how they're going to use blockchain in their businesses. So we started working backwards, and we started having these customer discussions, and we essentially found out that customers were looking for two separate solutions, right? There's one set of customers which essentially were looking for a system of record. They also wanted that system of record to be immutable, right? They were essentially looking for a ledger. They also wanted this ledger to be operated in a centralized environment, right? They didn't want to have a decentralized solution. So if you look at one of the classic examples, the DMV comes to mind, right? If you look at the DMV, it essentially has all the information of vehicles in a state, but it also has a historical record of all those vehicles, right? And so this is a use case for customers that essentially needed a ledger in a centralized system. So for this set of customers, we ended up building Amazon QLDB. QLDB stands for Quantum Ledger Database. And if you look at it, it has two main components, right? It has a journal component, and the journal essentially is the system which actually has the immutable record of all the transactions, right? And the second part to this is the database component, which holds the current state of all the data, and it also has an index history of all that data, right? So these are the two main components that essentially make up Amazon QLDB. So if you follow the arrows from left to right, when application data comes in, it's first written to the journal component. It's then actually going to the database from there. And obviously, when you want to query that data, you essentially talk to the database. You have APIs to query and get data out of this database. The second set of customers that we came across were the customers that essentially told us that they wanted to run transactions in a decentralized way, right? And this is a use case that really excited us. We essentially talked to a bunch of financial institutions that said they were interested in peer-to-peer transactions, and they essentially told us what was important for them was to be able to independently verify these transactions. We also talked to a bunch of supply chain customers, and these are some complicated supply chains which have a bunch of retailers, distributors in the supply chain, and they essentially wanted to have one single view of data that all the parties in the supply chain are actually looking at, right? We also talked to a bunch of mortgage lenders, and mortgage lenders essentially didn't want to have any sort of central authority or escrow services while they were actually doing some of these mortgage loans, right? So what does a multi-party business actually need, right? There are basically three things. It needs a way to independently verify transactions, where everyone within that network needs to verify these transactions. The second thing is they all need to look at the same data at the same time. And this is a huge problem, right? Like you look at supply chain, through the entire supply chain, everyone has like a different set of data and really doesn't make sense. The third thing a lot of customers told us was they wanted to make sure that the data was actually tamper-proof, right? So that's extremely important, and we'll go more into that later. Some of the current approaches that these customers were using, they basically had central authorities to kind of secure this data, right? A lot of customers were employing some costly escrow services, which were basically inefficient, right? So in comes blockchain, right? What does blockchain really do? Blockchain essentially builds trust in a network such that you can transact without a central authority, right? And how does it do that? Essentially it has three components. The first one is the distributed ledger. The second one is the consensus mechanism, right? And the third one is smart contracts. Together, these three components essentially provide the immutability and the trust, which essentially enables multi-party transactions without a centralized authority, right? We'll dive deep into each one of these three components now. So, what is a distributed ledger database, right? So this is a database essentially which has two main components, right? We talked about this in the QLDB slide, but the first component is a journal component, which is essentially having an immutable record of all the transactions. And the second component is essentially a database which has the current state and the historical state of all this data as to how it got to the current state, right? This is important because this is also the component when we get into more blockchain networks. It's also the component that resides on every node in a blockchain network, right? It's a super important piece. Consensus mechanism, right? So what is consensus? So this is essentially how a network agrees on transactions and blocks, right? And why is this important? Because this is also the key component that is different in different blockchain networks, right? Or other frameworks. So if you look at the Bitcoin network, right, it uses proof of work where everyone solves a complex puzzle, and whoever solves that puzzle first basically gets to mine that block. And there's various such consensus mechanisms depending on the framework you choose. Why is consensus important, right? So consensus essentially decides what the transaction rate of that network is going to be, right? So if you're looking for something that is high throughput, you would basically go with one framework versus something else. It also decides what the energy consumption is, right? And this is super critical. It also decides what your hardware requirements are, right? So depending on the framework and the consensus that you're going to use, your hardware requirements for some of these peer nodes are going to change, right? And it's also important from a security perspective because, depending on what sort of frameworks you're going to use, maybe they are private, maybe they're public, and it really matters because the consensus mechanism is the one that actually decides that. All right, now let's look at the third component. This is the smart contract component, and essentially smart contract is business logic code that resides on a blockchain, right? It's also the application that is used to write to the ledger. The way I look at smart contract is essentially the liaison or the component that enables outside stuff or outside activity that is not on the blockchain to talk to the blockchain, right? So this is how you actually write and read stuff from the ledger which resides on a blockchain. So kind of summarize all of this, we look at blockchain in terms of a three-layer stack, right? At the bottom of the stack, you have the distributed ledger component. In the middle, you have the consensus mechanism. And then on the top, you have the smart contract. And together, these three things enable organizations to transact without a central authority, right? It's pretty simple. So what are the challenges with existing blockchain solutions? So number one thing that we keep hearing from customers a lot, we see this a lot, is just setting up a network is hard, right? There's so many different frameworks. Which one do you choose? Once you choose something, like how do you set it up? That is not a trivial thing to do. The second thing is it's also hard to scale, right? So a lot of customers come to us and they're basically telling us that, hey, we were able to set up a blockchain network, but the moment we want to invite other members, like everything starts falling apart, right? So scaling a blockchain network is not a trivial thing either. The third thing I want to point out is, bringing up a blockchain network it's complicated to manage. There's so many different aspects. There's the security component of it. There's the billing component of it. How are you going to grow the ledger size as you start pumping in more transactions? Like, these are some of the real world challenges organizations are facing today when they try deploying these blockchain networks, right? The last thing I want to highlight, it's also expensive, right? A bunch of customers essentially are employing costly consulting services to build the blockchain story, right? And these are the customers that are coming to us saying that, hey, we actually need a solution that works and we want it to be cost effective, right? So these are some of the existing problems with these networks. So now let's go into Amazon Managed Blockchain, right? So what is Amazon Managed Blockchain? Amazon Managed Blockchain is essentially a fully managed service that makes it easy to manage scalable blockchain networks using popular open source frameworks, right? Today we support Hyperledger Fabric, and Ethereum is coming soon. Let's look at some of the features that Amazon Managed Blockchain offers, right? The number one feature is that it's a fully managed service, right? And why is this important? Because within a few clicks or a few APIs, you can essentially create a blockchain network in minutes using Amazon Managed Blockchain. And this is really important, right? We support open source varieties. Today we have Hyperledger Fabric and Ethereum's coming soon. We'll dive into both of these frameworks a little later in this presentation. It's also decentralized, right? Like, we built a bunch of features that enable you to democratically govern this network. The next one is it's actually reliable and scalable. So some of the things that we've done, we're basically using the same technology that powers Amazon QLDB. And what we've seen is using that technology essentially is adding more reliability and durability than what you get with just the open source code base. It's also low cost, right? So our pricing model is essentially you pay what you use, right? And if you're not using your resources, you can bring them down and you basically don't get charged for it, right? It's as simple as that. It's also integrated. And this is important because it's one thing to use some open source frameworks that are out there. It's a completely different thing to actually take them to production workloads, right? And this is where, like, we've actually integrated with a bunch of different AWS services like CloudFormation, CloudWatch Metrics, CloudWatch Logs. Even under the hood, we use technologies like AWS KMS. So these are things that just come off the shelf. Like, you don't even have to do anything about, like, trying to use some of these technologies to build your blockchain story. So how does this all work, right? So it's basically, I like to call it the 4-step process, right? The number one thing you want to do is, like, okay, I want to go and create a network, right? And the way to do that is you can either go into the console or via the CLI. You can choose what frameworks you want to create a network in, and you can essentially create a network in minutes, right? Most customers that we talk to don't even get to this first stage. Like, there's so much complexity in trying to set some of these things up, like, they essentially get stuck. So once you've created your network, right, like, the next obvious thing you want to do is you want to go ahead and invite members, right? And again, this is via the console or using some APIs. You can essentially invite other AWS accounts to join your network. So this is the scaling piece of things where, like, if you do it yourself, it becomes a little hard to kind of do this. We actually give you a programmatic way to do this in Amazon Managed Blockchain, right? So let's say now you've created a network, you've added a bunch of members, and you're ready to start running transactions, right? Like, how do you do this? And essentially, the way to do this is you start adding nodes. And nodes are important because nodes are the components where your ledger resides. It's also the piece where your smart contracts reside, right? And within Amazon Managed Blockchain, we give you a bunch of different instance type options that you can choose from for your peer nodes, right? And this is important, and it really depends on your application. If you're someone who's going to pump in a bunch of transactions, you want a beefier hardware or a beefier peer node, someone who's just going to be a dormant member and keep consuming, right? The last piece is important, like, and this is where you start deploying your applications, right? And when we say applications, it could be your smart contracts. It could also be your client-side applications that you're basically integrating blockchain into. And most customers that we talk to, they don't want to worry about the first 3 steps, right? They want to quickly get into the deploying application mode. And what we've seen, most customers that are trying to do this or, like, kind of do this in a DIY fashion, essentially are getting stuck at step number 1. And with Amazon Managed Blockchain, you can basically get to step number 4 in minutes. And that's the key value prop of this product. All right, so let's go into Hyperledger Fabric and Ethereum, right? So we talked about 2 open source frameworks. What are these frameworks, right? So Hyperledger Fabric is essentially a permission network. Ethereum on the other side is a public network, right? And why is this important, right? So let's say if you want to build an application that requires stringent privacy and it requires permission controls, if that's the key requirement of your application, you're going to use Hyperledger Fabric because it has a bunch of features that enables that, and we'll get into that later. Ethereum on the other side is basically used for applications where transparency of data is important, right? If that's important to your application, then you essentially use Ethereum. So let's look at a couple of examples, right? Let's say there's a consortium of banks, and these banks are essentially trying to run some peer-to-peer transactions, and bank number 1 and bank number 2 may have some trade-related secret that they don't want bank number 3 to know. You can actually do that with Hyperledger Fabric, right? Even though it's the same network where all the banks are involved, bank number 1 and 2 can actually isolate some of these transactions because they're secret or whatever, right? On the other side, let's come to Ethereum, right? Let's say if you're trying to build a network of farmers, and these farmers are essentially sharing data like crop yields, weather information, land data, and things like that. And the goal is really for all the farmers in a country to actually look at this data and make meaningful decisions from. If you have that sort of an application, then essentially Ethereum is a better fit for your use case, right? So the point to be taken from this slide here is there are 2 different frameworks. They're basically for 2 different use cases. So again, like, whatever fits, the use case and the business problem that you're trying to solve, like, you would essentially end up picking one of these frameworks. So question that we get asked a lot, who owns the network, right? And the way I like to think about it is that everyone owns the network. It's really a distributed ownership model, right? And the few things that we've done essentially, purely from a decentralized perspective, right? Let's say you created a network, and maybe after a couple years you decide that, hey, this network's not beneficial to me anymore, I want to get out of it, right? The network still lives on as long as the last member is there, right? And that's important because there are other members who are still part of that network who are extracting value out of it. The second thing is, we basically build a pretty good system around the governance model, right? So as a network, everyone in the network can democratically vote as to who they want to invite to join into this network, and also who they want to remove from this network, right? And again, this is important from a decentralization perspective. The last thing, and this is important to kind of highlight, is that every member essentially pays for the resources they use in the network, right? So we've done a bunch of things from the billing aspect of stuff where like you essentially are billed for resources that you use. And if you're not using those resources, you don't get billed for it, right? So we talked a little bit about, it's reliable, it's scalable. So I want to talk about how we've augmented Hyperledger Fabric, right? So Hyperledger Fabric has a component called the ordering service. And this is a core component of a Fabric network. I call it the heart of the system because it actually is responsible to kind of generate and cut the blocks. And one thing that we've done is, like, if you look at some of these open source frameworks, they're using Apache Kafka. And a lot of customers said that it's hard to kind of manage these Kafka nodes. Amazon Managed Blockchain essentially uses the same technology that powers Amazon QLDB. And we've seen, like I said before, like we've seen increasing durability and reliability when we use this component. The second thing I want to highlight is the certificate authority. And again, this is the service that is responsible for maintaining an identity of a member in a network. Open source recommends using a soft HSM. HSM technology is just, it's expensive, it's hard to manage. Managed Blockchain actually uses AWS KMS under the hood to secure the certificate authority service. And this is, again, like, things that we've done to kind of ensure that Fabric is more production grade and ready for production workloads. So let's look at some of the pricing dimensions, right? and this is important. I've said this before, but again, the model that we have today is basically a pay-as-you-go model, and there are no upfront fees for joining Amazon Managed Blockchain, right? There are 4 essential dimensions when you look at the pricing model for Managed Blockchain. The number one is being a network member. Think of it as being part of a tennis club where you would essentially pay some sort of a monthly fee to be part of a network. If you don't want to be part of that tennis club, you essentially stop that membership and you don't pay for it, right? So that's component number one. The second one is essentially the data that you write into the network, right? So if you want to just read data, there's no fee for that. But if you want to write data in terms of submitting transactions, then you'll basically bill for that. And at the bottom there, right, like we have a node, and the node is an important component essentially, right? And we've got a variety of options, right? So depending on the size of the peer node that you choose, essentially you get billed for that node. And also with the node, you have the node storage, and this is a piece where your ledger resides. So if you're submitting more transactions and the ledger essentially grows, you're essentially going to be billed accordingly. So again, key takeaway, there are 4 different pricing dimensions, and it's easy to model out what the cost structure is going to be. Let's look at different types of membership, right? So today we've got 2 different types of membership, right? There's a starter edition, there's also a standard edition. It's important to bring out that both these editions or both these types of membership are production grade. The only difference is that in the starter edition, you can expect to see little less throughput than what you would get from a standard edition. And most customers that we've talked to or seen, they're essentially using starter edition for their test networks or some small production networks, right? And customers that are using managed blockchain in some high-scale production volumes are essentially using the standard edition. All right, so let's go into Hyperledger Fabric on Amazon Managed Blockchain. So let's look at what that architecture is going to look like, right? We can dive deep into this service now. But essentially, there are 3 main components here, right? The first one on the top that you see is essentially the ordering service. And I actually call this the heart of the Hyperledger Fabric system, right? It's the component that essentially is responsible for generating the blocks and sending them to the peer nodes. The second thing that you see is the Fabric CA service, and this is essentially the certificate authority service, and it maintains the identity of a member in a network. The third thing is the peer nodes, and the peer nodes are the important piece that hold the ledger component. They're also important from a perspective that they're the ones that actually accept the transactions that are coming from outside applications, right? So how does this all work, right? So let's say I'm member A and I decide, hey, I want to create a blockchain network, right? Member A would then go into the console or the CLI and essentially create this network. And when that happens, Managed Blockchain behind the scene provisions the entire ordering service, right? And this is happening in minutes. For member A, Managed Blockchain will also create the Fabric CA service. And this is important because these 2 combined take a lot of time, and it's complicated, and customers have given us feedback when they've tried doing this themselves, they're essentially just getting stuck, right? So now we've got a network, and member A is part of this network. Member A decides that, okay, I want to invite member B and member C. They would essentially use the Create Proposal API, and they would send a proposal to member B and C to join this network. And when member B and C within their AWS console, they'll essentially accept the proposal, and now member B and C will join this network, right? When member B and C join the network, we automatically create their own Fabric CA service, right? And this is all happening as part of the managed service where you don't have to actually deal with trying to do this yourself. So now let's look at the situation where you've got a blockchain network, you've got 3 members in it. They're all going to wonder, hey, how do we actually submit transactions, right? So the next thing they do is they all want to now create their own peer nodes. And like I said before, peer nodes are the ones that actually store the ledger. They're also the nodes where the smart contracts of the blockchain network resides, right? So this is important. And depending on the transaction throughput that you're going to put in the system, you would essentially choose the size of the peer nodes that you really want to use, right? One thing I want to highlight is everything within managed blockchain and how you communicate with it, it's actually flowing over AWS private links. So it's again like, security is important. And we've essentially ensured with this service, like everything, all the communications are actually flowing via the private link. So let's say your account A, you build some sort of a client application to submit these transactions. Essentially your VPC endpoint would communicate over the private link and then talk to all these services within the managed blockchain environment. All right, let's go to how a transaction works in Hyperledger Fabric, right? So the three different entities over here, right? There's a submitting client. In the middle, you have the peer nodes. And on the right, you essentially have the ordering service, right? So step number one, a client essentially sends in a transaction proposal to these peer nodes. Peer nodes are the ones that are now going to simulate that transaction, and they're essentially going to send back an endorsement signature back to the client, right? The client doesn't really know what endorsements it has received. All it does, it basically packages these endorsements and it broadcasts those endorsements back to the ordering service, right? And like ordering service, essentially the heart of the system, it verifies some of these policies. It essentially takes these transactions, it'll cut them into blocks and ensure that these blocks are essentially delivered back to the peer, right? And the peer node would take these blocks now and make sure that they're appended to the ledger, right? And essentially, like that's what the transaction flow is for Hyperledger Fabric system. It's pretty simple, straightforward. You kind of do it once, you set it up once, and it just like follows path when the new transaction comes in. All right, let's look at channels and private data collections in Hyperledger Fabric, right? So this is another important feature that a lot of customers end up picking Hyperledger Fabric for these two reasons. And channels essentially are the way that enable transaction isolation among specific members in a network, right? So you look at this diagram here, you've got member one, member two, member three, and if member one and member two actually want to transact such that they don't want to let member three view that transaction, you can do that, or they can do that via channels, right? And this is an important feature because coming back to the banking example that I gave before, a lot of customers actually use this feature with Hyperledger Fabric because it enables transaction isolation, which is important for their business, right? The second feature is private data collections. And this is, again, important because a lot of customers are using data or PII data that they want to actually put into the ledger. And Hyperledger Fabric also has this feature where you could actually put some of these PII data in private data collections and ensure that they reside on the ledger, right? And again, depending on your business and your use case, right, we've seen customers use both these features, and this is one of the key reasons they actually like Hyperledger Fabric. So let's look at what endorsement policies are, right? Endorsement policies are essentially the things that allow Chaincode to specify which members need to validate a transaction before they get submitted, right? And again, it's a pretty simple thing. Most codes that we've seen essentially are single line and a bunch of and or operators, and all they're doing is just defining that, hey, we've got a network with, let's say, 10 members, but every transaction that comes in, member 1, 2, and 3, they all need to say yes for any transactions to go through. Essentially, those are what endorsement policies are. Excuse me. So if you look at this diagram here, you've got one member one client, and then you've got member one, which has a peer node, and member two, which has another peer node. Essentially, member client will send that transaction proposal to both these peer nodes. It'll get the endorsement back. It'll package those endorsements and then send them back to the ordering service. And then the ordering service essentially does the rest from there. But again, endorsement policies are the ones that you would essentially use to kind of decide that who needs to approve some of these transactions. Cool. Let's look at Chaincode now, right? Chaincode is essentially business logic code that resides on a network. It's also the way that you would actually query and write to the ledger, right? Fabric supports writing Chaincode in 3 different languages. You have Go, you have Node, and you also have Java. right? And what we've done with Amazon Managed Blockchain is like we've essentially ensured that every chain code is executed within its own container on the peer node. So again, like stuff that, as a customer, like, you guys shouldn't have to worry about like, hey, how are we going to actually use chain code and deploy them? Like we just do that as part of the managed service. Again, chain code sounds a little complicated, but fundamentally they essentially just have two functions. The first one is like how chain code is initialized on the network, right? So like how do you actually get chain code on the network and initialize with certain parameters? And once you've done that, you essentially invoke it, right? So you've got your client, you want to submit transactions, and the way you do it is just call the invoke function and essentially call your chain code from there. All right, let's look at peer nodes. Peer nodes are, like I said, a super important part of a blockchain network, right? And there are essentially three things that they do. They execute chain code and they endorse transactions. They also hold the ledger, right? And that is important. So if you want to query any data outside the ledger, you would essentially have to talk to the peer node. It also validates these transactions before these transactions are committing to the ledger, right? So let's say it's receiving these blocks from the ordering service. Peer nodes will then ensure that these transactions are right and they're actually meeting the policies before they're finally committed to the ledger. All right. Now I'm going to invite Shruti Rao, who leads business development for Amazon Managed Blockchain, to kind of talk through some customer stories.
Hi, everyone. Can everyone hear me? Good. All right. I am Shruti Rao, and I head business development for blockchain on AWS. And we've talked a little bit about how we came up with this blockchain thesis, why we have two services at AWS. We also talked about managed blockchain, and we talked about diving deep into the Hyperledger Fabric on top of Amazon Managed Blockchain. Now, the question is this still an experimental technology? Is someone really using this? Or is there any production workload? Or is this still a solution looking for a problem? Well, I'm here to tell you about three big buckets of use cases that we see our customers using blockchain for, and we will dive deep into some of these use cases with live customer examples. And then we will have Casey from Workday come in and present their particular use case. So of these three use case buckets, the first one is track and trace for supply chain. Track and trace of things, goods, or track and trace of data. Those are the two things that we look for, and then tracking and tracing is important to customers because now, with this transparency or with this provenance, they're able to make whether it's next step decision making, which you will see with a couple of our examples, or making payment decisions on the goods or the data that they have. That's the first use case bucket. And the second use case bucket that we see is settlements and clearing. Any type of an exchange transaction, retail transaction between multiple parties, insurance transaction, things like that. And then we will see a couple of examples there as well. And the third big bucket that we have is peer-to-peer transactions. They usually used central authority. Now they're disintermediating the central authority and some kind of a peer-to-peer exchange. I will talk about treasury finance, and Casey will talk about credentialing. So let's look at the first one. The first example we will talk about is Nestle. Nestle is tracking single origin coffee from farm to table on Amazon Managed Blockchain. What does that mean? So coffee is the number 2 traded commodity in the world. The first one is oil. And Nestle is one of the largest purveyors of coffee in this world. What Nestle realized was the producers of coffee, that is the coffee farmers, were the least equitable of the whole ecosystem. So they set out as pick coffee, single origin coffee as their first ingredient, and decided to track every handshake, beginning with the farmer, then the roaster, then the harvester, then the packaging company, shipping company, through to the end customer who uses it. So with this single origin coffee that Nestle has launched, you can go scan this QR code and you will find out who exactly picked your coffee, what part of the farm it was picked, what farm it was picked in, and who roasted it, and the entire ecosystem. If you sign up for this on their single origin coffee website, chainoforigin.com, then it will tell you that this coffee was drank by you, unless someone else in your house drinks this coffee before you do. It's a pretty good premium coffee. So I also have another bonus beer example at the end after Casey goes, but we will wait for that. What Nestle realized was not just a brand recognition and doing good, social good. By tracking every step, now they can find out where single origin coffee, which comes from one farm, is becoming out of provenance, which is becoming a double or a triple origin. So think of this as for beef or spinach or romaine lettuce. If it becomes a second quality ingredient or if it becomes tainted, there is no way for our customers to know where exactly or which beef got tainted or which romaine lettuce got tainted. So they recall all of the beef or the produce from a particular city. Now, with this tracking and tracing technology, they can pinpoint which two of these retail outlets indeed have the tainted product and recall that. Recall management becomes easy. Also, if there is a pattern of a particular, let's say, trucking or a distribution company losing the quality or the provenance going out of bands, then they can, make payment decisions based on that particular data point that they have, which was not available for them because they used emails and Excel spreadsheets or sometimes just clipboard and a pen to track these ingredients. That's the first one. The second use case in our track and trace category is Sony Music Entertainment of Japan. So we talked about track and trace can be both goods and data. This is the data example. Sony Music Entertainment of Japan realized that in Nestle's case, it was farmers. In Sony's case, it was they realized the music producers, composers, artists were spending more time actually filing for paperwork, IPs, trademarks, protecting their intellectual property than actually producing music, good quality music. So they have come up with a platform that music producers and composers can put their music on, track the lineage of their music, and effectively monetize it. So giving the money back to where it belongs to the music producers. So the second use case bucket that we talked about was settlements and clearing. So Singapore Exchange, or SGX as it's known, is a pan-Asian exchange of all type of assets, securities, bonds, exchange-traded funds based in Singapore. Singapore Exchange has been working with Monetary Authority of Singapore, which is a government entity, to bring more liquidity into Singapore market. So every time a trade is executed, let's say a share of stock is I sell a share of stock. My bank's involved, I am involved individually, in this case Singapore Exchange is involved, the buyer is involved, and their buyer's bank is involved. And the way this is settled is information about me, my share, and the buyer's share goes back and forth multiple times before the transaction is executed, settled, and cleared. That is, I get my money, and the money from the buyer is been recovered. Now, but that's not how it looks from a consumer perspective. When we sell shares, we immediately see our money, let's say 24 hours. That is because any exchange, including Singapore Exchange, fronts the money, which increases their risk appetite, risk spread, and they have to now have less liquidity in their treasury. So working with Monetary Authority of Singapore on this project called Project Ubin, a DVP, or Delivery versus Payment Mechanism, was created. What DVP does, it establishes an inter-ledger connectivity. So multiple entities like Singapore Exchange, multiple banks, and multiple individuals are all now connected, and all of these ledgers at different places are connected through a blockchain, which is based on Amazon Managed Blockchain. Now Singapore Exchange can decide this particular transaction I want to settle immediately, and another transaction I want to settle tonight in terms of a batch process because it's not as critical to be settled. So they have ad hoc, on-demand ability to settle transactions. Another example of settlement and clearing is Legal & General is the biggest reinsurance and pension insurance marketplace in UK. Legal & General has multiple pension plans, and all of these pension plans are then reinvested in whether it's investment banks or venture capital funds, so on and so forth. let's say when I retire and when my pension is called for, that needs to be recovered because payment has to be made to me. Legal & General is in the business of reinsuring this, so even when my pension plan has been invested in long term, Legal & General makes sure that I am paid on time. So Legal & General has about 100+ different pension networks and pension plans that they work with, and they settle transaction and balance risk spread in between these. So consumers like you and I are paid on time, and we get our pension when it's due. And all of their system is based on Amazon Managed Blockchain on their platform called S2RA. Right now, they have about 100 pension plans subscribing to this network, and they plan to add more. The third big bucket, the third one we talked about, was the peer-to-peer transaction and disintermediating the process. Contura Energy is one such for treasury finance use case. So Contura Energy is the largest supplier or exporter of metallurgical coal, and this coal is used to make stainless steel. They're the largest supplier in the United States, and they export about 5 to 8 million tons of coal every week. So when Contura Energy used to sell coal to their buyers overseas, some in Ukraine, in Turkey, in Brazil, India, and many of the EU nations, the buyers are paying some form of a supply guarantee, some type of a guarantee that the buyer will make the payments to Contura. Usually this takes 6 months, where there is a purchase order that comes in from the buyer that says, we want 5 million tons of coal this week. Contura says, well, okay, show me some kind of a payment guarantee. So the buyer's bank acts as a creditworthiness substitute for the buyer's creditworthiness substitute. So there is some kind of a protection for Contura to recover their working capital. So this process, back and forth process, ended up leaving Contura to recover their working capital in about 6 months. So the coal that was sold today, the working capital was recovered about 180 days later. With the Amazon Managed Blockchain-based process, that time will be reduced to 21 days, and they are in process of moving all of their processes to Amazon Managed Blockchain. A quick fact about the letter of credit process is the last time the rules were updated on letter of credit process was in 1933. It has gone from a paper-based process to an email-based process. That's the automation that has happened in this industry. Another quick example is when a purchase order comes in through a SWIFT for Contura Energy, if a spelling has been wrong or boulevard is spelled as BLVD with a comma, that wrong spelling has to be replicated in all documents. If it's not replicated in all documents, that deal will have to be disparaged, and they'll have to start all over again, increasing the 180-day process to about a year. So with Amazon Managed Blockchain smart contracts and using Amazon Textract, now Contura Energy is able to avoid all of that, avoid the human error, and then make sure that typo is replicated in all documents and enforce it within the smart contract. So we have some other great examples. We will get Casey now to talk about how Workday is using Amazon Managed Blockchain, and then I will come back and give you the sneak peek about beer that I mentioned earlier. Casey.
Thank you.
Thank you.
Hey everyone, can you hear me? Cool. So my name's Casey Lucy, and I'm an engineer at Workday. Workday is the leading provider of enterprise cloud applications, including financial management, human capital management, planning, and analytics, all designed for the world's largest organizations. I helped design and build the blockchain infrastructure for a new product called Workday Credentials. So let's start with what credentials are. Credentials are a way of proving our identity or qualifications. If you traveled here by plane, you had to show your photo ID, which is a credential issued to you by the government that proves your identity. When you go to rent an apartment, you have to provide proof of income or employment. This is often done by emailing or printing your pay stubs, sending them to the rental agent, and then the rental agent has to verify the content. Workday Credentials provides a secure way to share and verify this information without the need for physical documentation and human verification. So in the center of the screen here is an example of the Workday Credentials UI. Customers can use the Credentials UI or the underlying APIs to configure, issue, and verify digital credentials. Let's say, for example, that Sarah is an employee of Global Modern Services and she recently won the Employee of the Month award. Global Modern Services wants to offer free ice cream to the Employee of the Month, so in order to prove that Sarah is the Employee of the Month, they'll issue her a credential. If I was the admin at Global Modern Services, I would go to the UI, select that credential template, and issue the credential to Sarah. On the right side of the screen is the Way2 mobile application, which is a way for users to control and share their credentials. This is Sarah's first credential, so first she'll be asked to onboard to the platform, and once she does, she'll be able to store her credentials on her mobile device and share them with whoever she wants. I'll go through the process of Sarah onboarding to the platform in a few slides. So how do these credentials tie into the blockchain? We use the blockchain as a shared source of truth for public keys and other data necessary for sharing credentials. Blockchain provides us with a solution for interoperability with other partners through a consortium. Members of the consortium can read and write information from the blockchain independently. All of our credentialing services and APIs are built on top of AWS using things like API Gateway, Lambda, DynamoDB, and Amazon Managed Blockchain, among a whole suite of others. Throughout the user onboarding, credential issuance, and verification process, we use Amazon Managed Blockchain as a trusted source of truth for public keys, the shape of the credentials, and a registry of revoked credentials. Amazon Managed Blockchain abstracts the complexity of running, growing, and operating the blockchain network, allowing us to focus on what we do best, building applications. So how do we use all of these services throughout the platform? Going over a few key components, we have a blockchain adapter service, which runs as a set of lambdas that's responsible for abstracting the ledger from the rest of the platform. We have a blockchain administration service, which is also a set of lambdas that we use for modifying the running network, things like installing Chaincode, upgrading Chaincode, and changing the channel configuration. We have a ledger client service that's responsible for invoking the Chaincode to read and write from the network. And throughout the platform, we use DynamoDB as a store for metadata and as a temporary store for objects that are destined for the ledger. So let's go back to the process of Sarah onboarding to the platform and show how that goes through this flow. When Sarah registers with the platform, a key pair is generated. That private key is stored in the secure enclave of her mobile device, and it never leaves. The public key is sent to the platform in the form of a DID document, essentially a format for storing public keys on the ledger. The DID document is written into DynamoDB, and the DynamoDB write operation triggers a stream event. That stream event goes to another Lambda, which takes the record and writes it into an SQS queue. The SQS queue feeds into our ledger client, which is responsible for using the Hyperledger Fabric SDK to invoke our Chaincode, gather the endorsements, send the transaction to the ordering service, and wait for the transaction to be committed. Once Sarah's public key is committed to the ledger, it can be used to issue and verify her credentials. In this case, Global Modern Services is issuing her the Employee of the Month credential, so they also have a key pair, and their public key is already stored on the ledger. When Sarah wants to go get her free ice cream, she has to present her credential. The request to present her credential is signed using her private key, and the credential itself is signed using the private key of Global Modern Services. The verifying service has to read Sarah's and Global Modern Services public keys in order to verify the contents of the credentials. Using those values from a shared source, they can verify the fact that the credential was issued from and shared by the correct entities. The process of reading from the ledger is fairly straightforward. It's just an API gateway request to the blockchain adapter service which in turn calls into the Ledger client, which again uses the Hyperledger Fabric SDK to invoke the Chaincode and return the response. Earlier I mentioned that Amazon Managed Blockchain helps abstract the complexity of growing and operating the network. This is an example of the proposal console page, and in the center of the screen, you can see a proposal to invite a new member to the network. These proposals can be voted on by current members of the network, and once they've been approved, the new member can use the console or the underlying APIs to accept the invitation, join the network, and create their peer nodes. We also get some metrics from the service. This page shows the detailed view for a single peer node, and at the bottom left, you can see the number of transactions being committed to that node. We can also see the CPU and memory utilization metrics, which help us understand the load on the system and determine the right size for our peer nodes, so we're not overpaying for huge nodes or limiting ourselves in terms of performance. I'll hand it back to Shruti to close us out.
All right. When we talk about blockchain, whether it's Amazon Managed Blockchain that you choose for your decentralized workflow, or you choose Amazon QLDB, Quantum Ledger Database, what's important is what happens before and after blockchain process. That becomes very important. So within AWS, we have one of the biggest portfolio of event-driven services that help you design your process. So all of the services that you see above the boxes, the blocks, are services that our customers typically use to write on the blockchain, from compute to an API gateway to CloudFront to Cloud HSMs and IoT devices in case of some of the supply chain use cases that we talked about. And all of the services in the bottom are the ones that are used to read from the blockchain. And together, these make for a very powerful ecosystem where most of our customers take advantage of to create create and execute their blockchain services. So now the time for the beer conversation that I promised earlier is there is another company, Kabrew. Kabrew Breweries is the largest brewery and oldest brewery in Korea, and they have Jinju beer. And this beer is available at our beer pub, and this beer has been on a blockchain, so it's a special beer. So pick your poison, whether it's beer or coffee. Both of them are available in our Aria Quad in level 1. And please visit our booth, and if you answer a trivia question, you also get to win a t-shirt there. And we will say that there are some of the other things you can do to learn more about both of these services, QLDB and Amazon Managed Blockchain. All of the documentation is available online, and this particular slide share will be available on SlideShare through your app. And we also thank you for the opportunity to present to you, and please take the survey on your mobile app, and we really appreciate your time.